So cracking is the subject of this video. So our aims in this video are first to understand what cracking actually is, to understand the difference between thermal cracking and catalytic cracking, and know why we would want to carry out this process called cracking. So during fractional distillation, we make a number of different hydrocarbons, or rather we separate out the hydrocarbons that are in crude oil. And a lot of those hydrocarbons, or the vast majority of them, are long-chain hydrocarbons, or very long-chain hydrocarbons, if you like, much longer than what I've drawn there. Cracking is basically the process in which we break a carbon-carbon covalent bond to create two different compounds. One of them will be an alkene, and one of them will be an alkane. Now the conditions to do this are different depending on whether you do thermal cracking or catalytic cracking, and we'll discuss that a bit later on. But the important thing here is just to understand that you're breaking carbon-carbon covalent bonds during cracking. So here's an example of a question they may ask you on cracking, and it basically takes a little bit of common sense to do this. So it says, write an equation to show how one molecule of C14H30 is cracked to form one molecule of C8H18 and one molecule of another hydrocarbon. So all we've got to do here is write out C14H30, and that's the only reactant. The tendency here for students to get this wrong is to write something else with that, but it's just saying that that is the thing that's being cracked, and when this is being cracked, that's the only reactant here. That makes, it says C8H18, and then it says just one molecule of another hydrocarbon. So all you've got to do is work out what that other hydrocarbon is. All of these atoms on this side are going to end up on this side. You've already used 8 carbon atoms. There were 14 to begin with. That means there must be 6 left over. So your other hydrocarbon is going to be C6. And then you do the same for hydrogen. You've used up 18 of these 30 hydrogen atoms, so therefore it's going to be H12, because 30 take away 18 is 12. So that's going to be the answer to this question. And it's quite a straightforward question, really. You should be grateful if you get that sort of question in an exam. Now, there are 2 types of cracking that are used that have different conditions and produce slightly different products. So I'm just going to draw a small table. So we've got thermal cracking, and we've got catalytic cracking. Now, thermal cracking requires a high temperature, as you may expect with the name thermal, and a high pressure. And the main things that this produces is alkenes. A catalytic cracking process requires a high temperature, only a slight pressure, and to make up for that difference, it uses a catalyst. Now you have to know the name of this catalyst, and we call it a zeolite catalyst. Actually, the word zeolite only describes what how the catalyst is made up, as in the structure of it. And a zeolite catalyst is a honeycomb structure in that it has lots of holes in it, which increases the surface area. So if you're ever asked why a zeolite catalyst is used rather than, say, a block of metal, it's because it has a honeycomb structure which increases the surface area. And you know that if you increase the surface area of a reactant, although this is a catalyst, not really a reactant, but it will increase the reaction rate as well. You're not expected, well, you don't need to know the actual substance that is the catalyst. This is what they're looking for in an exam if they ask you what the catalyst is for cracking. This doesn't make as many alkenes, this makes mainly aromatic compounds, and that is a word that we use to describe things that have benzene rings in them, if you've come across those before. Don't worry if you haven't, you won't be asked what catalytic cracking produces. You'll be mainly asked, if you asked what sort of stuff these produce, you'll be asked this one, that alkenes are produced from thermal cracking. Finally, what are the economic reasons for cracking? Well, if we've got a long chain hydrocarbon that we make basically the most of after fractional distillation, that isn't very much in demand. It's still useful, and so it's important that you don't use the words that it isn't very useful, or it makes more useful products. It is still useful, but it's not as in demand. It's useful, but we don't use it as much. So what we have to do is crack this to make higher demand products, which therefore carry more value. You can make more money if you can sell all the product you're making rather than just some of it. So we're not going to say you'll make more useful product, we're going to say that it is higher demand or higher value product. So cracking produces higher value hydrocarbons, such as petrol. So we turn something that is not as high value into petrol, which basically you cannot get enough of petrol. It'll always be used and be useful.